Hello and welcome to this video about, well, I was just checking the comment section of this tutorial about the camera of the Octopath Traveler game, and one of these comments, both are great ideas and we'll tackle them eventually, but the one that I'm gonna do this video is this one, made by ADB Trist team. And they say, please consider do a video tutorial about real loading screen system, not a widget with a delay. And that's exactly what we'll do today. Oh, let me pause that video. There it is. And here I have set up a little example. This is the default map. I created a little blueprint I called a portal that receives a level to load, and what it does is load that level. I have cubes that makes the little portal and a box trigger that when you go and overlap it, then you just load the level, and here is the variable that we will load. So we can press play, and let me open up the console and type stat levels. You can open up the console with the tilde key and you can see the level that has been loaded. So let me load this new level, and it takes a while. It's a level that comes with an asset pack. I'll put the name in the description. I really don't remember. It was free, like, I believe months ago. So this is a nice level. And we can see that the level has loaded in 1.1 seconds. The thing is, if you notice, and maybe the level is now in memory, but so it could take less to load, but the first time we played, the camera freezes and it's not very pleasant. What most people do, and it has to do with this comment, like they use a widget with a delay. I have a widget that I will be using for my loading. Here's a portal, and my widget is pretty simple. It's just a black screen. I have a thrower, so it animates, and I have put some sprites of the characters of the Octopath Traveler, just to keep up the theme. So let's put the widget and see if that works. So for example, PP portal, I could put the widget here in between, so it stays in the screen. Let's see how that looks. Let's create a widget. And it's called loading screen. Let's add it to the viewport, so it can be shown. And now let's play. And I have my widget, that my loading, and I'm doing air quotes. I do not have my camera turned on right now, but I'm doing air quotes because yes, it's a loading screen, but it's more of a splash screen because it's really static. And people tend to fake this by doing a delay. If I add a delay here, let's say 2 seconds, no, just enough so the widget shows some movement, and we say that it's loading, but there it froze, right? And that's not what our viewer is asking. He wants a real loading screen that is not just a widget with a delay. And I agree completely. So let's make a loading screen that can support also these animated loadings that you can put inside. So let's get rid of this. And I have already set it up. So the result will look something like this. Let me change the map. And that's kind of the key of how we're doing this, and everything is being done in blueprints. And we even see how much the map is taken to load, and we are playing the loading screen while it happens. If we didn't activate that stat level, then we wouldn't have a clue that the map is really loading. It would look something like this. And yes, you can see some artifacts. To fix that, you could extend the loading screen like with a little delay, just to get everything loaded before showing the map to your players. So how do we do this? We're doing something called level streaming. What's level streaming? Let me illustrate that. Any level, let me move a little bit. Let me clear this. So level streaming is a way that we can have levels inside other levels, and we can decide when to load them or when to unload them. For example, if I had this persistent level called, usually the level name -p, and well, if you want to be more strict about it, you can call m level -p. This would be the root of every sublevel that it's inside of it. Level streaming can be used for organization purposes. What this means is that I could have the level, like the root, then I could have, and I'm gonna type it so I don't have to draw with my mouse. I could have m level art. I could have m level lightning, and this is a great way to divide one level so multiple people can work on it, because the level is a binary object, and if you're working with a team using source control or something technology like that, you could run into the trouble that whenever two people modify the same binary object, you would need to choose between one or the other. You cannot merge those changes. So doing something like this, it's a good way to organize your level. But level streaming is not only for organization. It is used also to load on demand some levels, or delete, well, not delete, just unload the levels. For example, you could have a big map called I don't know, city level, and -p. The root level is usually -p because it's the persistent level. In order to have sublevels, you need to have a level that will be always loaded, and that level that is always loaded is the persistent map. So the city could be subdivided in different districts. Let's say four districts, three districts, so I don't have to type too much. So I could have city district 01, and let me copy and paste that, 02 and 03. Let's put 04, so it's a little bit different. Every sublevel you can decide if it will start loaded or unloaded. If it starts unloaded, it means that you will probably decide when to load it through blueprints or code. So let's say that your spawn point is in the district 1, then you would probably put this sublevel in a state that is called always loaded. And the other level, they can start unloaded. So let's say you start walking near one of these districts, then did I type this wrong? I typed district. Yeah, I did. But you know what I mean. I'm just bad at typing. I'm just a programmer with dyslexia probably. But let's say that you're walking towards a near bridge that is near this district. You can then tell it to start loading asynchronously. So it loads while you are playing. You maybe experience some little slowdowns here and there, but it will not be that drastic like we saw the screen freeze, right? It will not freeze at all. It will load the level asynchronously, and depending on how large this is, you can mix and match like dimensions to get the best result for your map. But why am I explaining all of this? Because the way that this loading screen is working is that we have our map. Let's call it m level name, that persistent. We have a level called loading screen. That will be always loaded. And the real level that will be just called m level name. So what will happen in the code will be that first we will open the m level name -p. This is exactly what we're doing. It's m environment set map -p. And when we open this level, because the loading screen is always loaded, here in the level blueprint of this level, we will first show the widget. Well, create and show the loading widget, and then we start loading the map. Start loading m level name. And after that, we just ask if is the level loaded, and it's usually denoted by this kind of graphic. And if the level is loaded, then we just hide the loading screen. or destroy it, whatever you wanted to do with that. This would be if yes, and if not, no, then it's still a loop because it's being loaded and it will eventually end. So that will be the workflow, well, the flow of the code that we'll be doing. So what do we need to do? We need to first, in the part that we're calling the open level, we just need to call for the persistent level, and we need to set up this persistent level. So let me show you, and hopefully it runs fast. Let me, here it is. Let me go to this level, environment set, yeah, save selected. This is the level that the normal level where you just create stuff. I have duplicated the same thing like 4 times just to make it load longer. So this is our normal level, and if we go to the tab called levels, if you don't have this tab, you can open it in Windows, levels, and I just dock it here because it's convenient for me. We have that this is the persistent map, this is the persistent level, because every level we create is a persistent of itself. But if we wanted to add other levels, we just right click, create new if it's a empty level, or add existing if it's an existing level. I want to create a persistent level that has this already created level as a sublevel. So how do we create this? Let's go to true loading screen because the other folders are just for testing. So let's say I'm gonna duplicate this level just so it's clearer, and let me find it. Level, and I'm gonna find it. Yeah, this is it, right? Yeah, this is it. Let me duplicate it, move here, no, copy here, and I'm gonna call it the same name I have here, level name. I'm calling it level name because it really can be any name. We want code that can be reused a lot, so it really shouldn't matter what the level is called. So here, level name. So this is my level that has all the information of what I just put inside the level. I need a persistent level to hold it. Let's right click, level, and let's call it m level name -p, because this is a persistent, and it's important to maintain some order when naming things, because this way we can help a lot on the side of the code that we will program in a minute. So maintaining this naming convention consistent will help a lot. And let's open the persistent level. It will tell me if I want to save. Yes, I want to save it. And my persistent level it's completely empty, and it's alright because there really shouldn't be any information, because I want to load this persistent level as fast as possible. And now I want to add the sublevels I want to load. First, let's add an existing one. Let's go to my true loading screen, and I want to load the level name. it would add the levels. And now we have almost exactly the same, with the difference that I'm currently loading the persistent level, but the persistent level includes a sublevel called the M level name. Here, if you see, it has a dot. This means that it will be loaded. It would not be loaded automatically. We will have to load it by blueprints or by code. So if I press play, I would get everything black because this is not loaded. Let's try it. Yeah, there it is. There's nothing. But if I right click and I change the streaming method, instead of blueprint, I choose always loaded, the dot will disappear. And when I press play, the level will be already loaded. So I don't want the level to be loaded, because if I did that, if I load the persistent level, it would take the same amount of time that it was taking before. So let's return it to change stream method and blueprint. By the way, when working with sublevels, it's important to know which one is highlighted and in bold letters, because that's the level that it's being modified right now. You can toggle locks, so any modification it's not done by accident, but double clicking on the level will make it the current level, or right click it and make current will make it the current level. This means that if I drag and drop, for example, this cube, I'm adding this cube to the M level name, but I'll delete that. If I double click persistent level and I right click this cube, then I'm adding it to the persistent level. So if I toggle the visibility of my level, my normal level, then the cube will still be there. And if I toggle the visibility of my persistent level, then the cube disappears because it's in the persistent level. Having said that, it's important to assign stuff like the player start to the persistent level. It's even more important if the sublevels are not being loaded by default. So let's find the player start here, and let's press F so we can know where it is. And here, to pass it to the other level, I just need to select it, go to levels, right click on the level I want to move it to, and move selected actors to level. This has changed the current level, and I can see selected actors right now in level name persistent. So if I selected anything that it's not in the persistent, selected actor in M level name. This is in the persistent, then it changes a lot. Now, what would need to happen for this to work with our loading screen? What I said in the diagram, we want a loading screen map, and we are putting the logic in another map, because if I put the logic in this level blueprint, I could do it. I could open the level blueprint of the persistent level, and here I could load level streaming, load level instance. Let's choose it like this, and my level instance, it's called level name. I could give it a location if I wanted, and if I press play, it starts loading. And because my player start was near the ground before it loaded, then I just fall through the ground, because the ground loaded after my pawn loaded, my character loaded. So yeah, but this would mean that in every persistent level I would need to add this code. And not only that, I would need to add this logic that create the loading widget, start loading level name, and it will work, right? It's just a lot more work, and given that it's a task that is being repeated over and over again, then it will result in human error, because when humans do something repeatedly, they they are more prone to make mistakes. So yeah, let's create a loading level that will be always loaded, and I could create a new because I don't want anything in my loading level. It's fine if it's an empty level. Let's call it m loading level. I could also call it loading map or whatever. I believe I have another asset called loading map. Let's save it, and just let me make sure that it's not the same name so I don't get confused. Loading map, yeah, it's alright. And we can see what's in the loading map, but the setup will be persistent level. It's okay. The level name, that it's the level with all the content of our level, should be in blueprint, stream method blueprint, and the loading level should be always loaded. And because it's always loaded, I can add this to the I can add code to the level blueprint, and I'm sure that it will always load and it will always run, because first it will run any code in the level blueprint of the level name, and after that it will run any code on the level blueprint of the sublevel m loading screen. Well, it's called level. I called it here loading screen, but it's almost the same loading level. You can call it what you want. And let's see the code that the loading level should have. For example, I could add the existing loading map. That here it is, maps, loading map. And here in my loading map, I will delete this. I was just showing how to set up if you want it. But this is the code that you should add to your loading level. Let me remove. Removing levels will not be undone. Yes, it's okay. Loading map will be always loaded, and in the level blueprint I have this chain of events. What am I doing here? First, I'm creating the loading screen widget. That's exactly as I have it here. Create and show the loading level. This creates it, this shows it. Now I save a reference, so later I can remove this loading screen widget from the viewport. And here is I'm air quoting again, the magic of this code. First, it gets the current level name. The current level name will be the persistent map. So here, it will return, in this case, m level name. And if for any reason your map changes the name, it will still be fine as long as the sublevel is named exactly the same. Because what this is doing is it returns the level name. We do a left chop, so we are basically removing we're removing this p, these two last characters, the dash and the p, the persistent. We're removing it with the left chop, and this will return the level name that I want to load. So that's why being consistent with naming can help you a lot. And this will load the stream level by name, because I have the name here. I don't have to do a hard coding, put in here level name, and nothing like that. With this code, it doesn't matter what the level name is called. We just remove it, the persistent part of the name, and load it. Here we are printing a string that the level has been loaded. And this is an asynchronous node because it has this little icon of a clock. This means that this node will not finish, well, it doesn't necessarily finish the same frame it was called. This pin will trigger when the level stops loading. So when it's all loaded, here we said that we want to make the level loaded visible, because you could load a level into memory and not show it. It's fine. You can do that, just so it can be loaded quicker. So you can have another part of, for example, the district that we were talking about here. Like I could have district 2 loaded in the memory, but maybe it's too far away, so it shouldn't be seen. So I could load it and not make it visible. And well, putting this check of should block on load will convert this node into a synchronous load that freezes your screen. So we don't want that. We just want to load the level asynchronously, make it visibly as soon as it can, and when it finishes, I will show up a string that the sublevel was loaded, remove the loading screen, because this is the same reference we are setting here where we loaded, where we created the loading screen. And then I will explain this part of the code later. Do not pay attention for now to that. So let's test it. Here we have the loading map. Let's play it. And there we have it. It worked, and I'm gonna put again the stat levels so you can know exactly what is happening. When I play, the map is loading, and while it's loading, the loading map shows the screen. And I have a lot of loose performance because I have not built the lightning of this level. So whenever I will go to the persistent map that does have this lightning rebuilt. Yes, save it all. And you can see that the setup is exactly the same. We have a persistent level, we have the sublevel that it's called the same, except that it doesn't have the dash p at the end, the underscore p. Yeah, that's it. The dash is like the same line but in the middle. So this doesn't have the underscore. So whenever the loading map tries to load it, it just removes the underscore and loads the level by name. And the name, it is getting it from the persistent level. And if we play it, then it shows the loaded level. Now, Stuff that you can run into while doing this kind of setup will be that your player controller will fall to the ground. And what I mean by this, let me remove this third person game mode. That because I'm loading too fast. Let me go to a start map. No, this is not the start map. Start map. Yeah, save it. Because the yeah, it's being loaded too fast. Because the sometimes, especially when you just open the engine, and it would happen when you just open your game whenever it's packaged. Whenever you do that, you need to load all the stuff into memory, and that takes a little while. So whenever you start loading it, you may fall through the ground like this. And yeah, I wait a minute just for some assets to start being unloaded. And this happens because when the level loads, it's called like the world, and anything and everything will be instanced there, and the game mode will load the default pawn here. Well, wherever you put the player start. So if your player start is here, whenever this level loaded, the game mode, if you have set it up, will load a pawn there. That, well, this is an empty pawn, but I'm using the third person character. So it will put it there, and this character has physics. So if there isn't a floor there, it will fall, and that's exactly what is happening. How can we fix that? So our pawn doesn't start floating around and falling through the level. It's actually pretty simple. You just need, let me go to the level I was working on here. Yeah, save selected, why not? Here's my level, the persistent level with the normal level and the loading map. Let's see, search the player start. I have 2 player start, and this has happened because one, it's in the M environment set map, and the other one is in the persistent one. This one in the M environment set map that has all the content will not be used because it's not loaded with the starting level. Because whenever I open this map, remember, this is not loaded, so I'm only gonna see this. And there is my player start. So the thing to fix this issue with the falling character, you just need to create a game mode. Let me, yeah, create a new game mode. I'm gonna put it here. I can add new folder. Let me call it blueprints, and I will call it game mode. And I don't know, level loading. You can call it whatever you want, really. It doesn't matter. So here I have the level loading. Here I will put the third person character. I'll press play, and well, it's working fine because I'm not loading it from another level. Let's load it from another level. So we are back to the error of falling through the map. Yes, save everything. Ah, there it is, yeah. And now in the game mode I just created, level loading, I'm gonna check the start player as spectators. by doing this check, the game mode will not assign a default bound class to the default player control class. So whenever I press play, I go to the level and I stay stationary as a spectator pawn that doesn't have gravity and have the movement of flying around, and I believe it doesn't have collision either. Yeah, it supports. Yeah, it does have collision. So now we're not falling through the map, but we do not have a pawn. What we need to do is assign the pawn when the level has been loaded. And which part of our code has the information on when the level has loaded? Yeah, you guessed it right, is the loading level. In our case, is the loading map. And this loading map in the level blueprint, I'm opening the level blueprint with here. You can also open it, blueprints, open level blueprint. And here I know that whenever this node finishes, the level has been loaded completely. And with this node that I'm calling from the game mode, and with the controller, I can restart the player, and that will make the game mode give, oh, this is an empty level, I'm sorry. This node will make the game mode give that spectator player a pawn, that the default pawn that can be used, that we have set up as a third person character. So let's see if it works. The start map, save selected, and here we have the start map again. Whenever we go through, the level is loaded and it gives me the pawn that I wanted. So that is the way of how we can do actual loading level screens only with blueprints. I believe this video has gone a lot longer than I wanted, but it gives you the starting point of the concept of level streaming, how to use it, how to create a loading screen. And the setup is really simple. Any map you have, you just need to right click. Let's say I have this map, this environment overset map. Just copy the name, just level, paste the name, underscore p, because that's the persistent. Yeah, save it. In the persistent, add the level, add existing, and I call it this one, environment set over map overview, open. Now we have the content we need. We let it be blueprint, the streaming method, and then we add our level, add existing, our loading level, that I will put that code in a paste bin, so it's easy to copy and paste. But we have shown it a lot of times in this tutorial, so it shouldn't be a problem. And the loading level, be sure to change the streaming method to always loaded, so the code inside it will run. And now, whenever we want to load this map, we don't call this one, we call the persistent one, the underscore p. And that's how you set it up. And even here I could play, it would show my loading map. I believe I do not have here I do not have a player start. Yeah, be sure to put the player start inside of a surface that has collision, so you don't fall through the ground. So here I double click, so this is the current level. I drag and drop the player start, and now it should work. properly. So yeah, you can set up whatever you want here, and if you want to add a delay so maybe your map loads too quickly, you could add a delay here. Delay, I don't know, just to show that the cool animations of your loading screens. Here it is, 4 seconds of delay where I do not have control. And there it is. But yeah, we really don't want delay. We don't want to make the player wait for no reason. So hopefully this was an useful video to you guys. Keep recommending stuff. We love seeing your input and the questions you ask. So yeah, have a good one, guys. See you in the next video.